So I have a character or a pawn that I'm trying to move to an actor, and I'm using AIMoveTo. I'm telling it to move to the actor, but when I press play, I'm getting aborted. Now if I look at Vizlog, I can see an error reported by the AI controller trying to find a path to the actor resulted in an error, and if I look at the recast NavMesh, I can see that pathfinding endpoint is not on the NavMesh. It's reporting a red error right where the actor is because there's no NavMesh here. And if I look at the sphere at the Boolean, can ever affect navigation, that's checked. So no NavMesh is being generated under the actor. So when I tell AIMoveTo to go to it, it fails. What we want to do is calculate the closest point to the actor that is on the NavMesh. In this case, it would be a location right around here, and move the character to that point instead. So in this tutorial, we're going to create a function that gets the nearest nav point to the actor so that we can plug an actor into it. It'll find the nearest point that is actually on the NavMesh and return that location so we can plug it into the AIMoveTo and we won't have any errors anymore. Now this is a really basic setup. I just have a blank scene with a plane. I have a NavMesh bounds, as well as the default recast NavMesh. I haven't made any changes on the default NavMesh. And my character, I just right-click, blueprint class, and created a character blueprint. And the only changes I made to the character were I changed the skeletal mesh asset, but there is no animation. And I also set auto possess AI to placed in the world or spawned. And this just makes sure that the actor in our scene is being controlled by AI and not a player. So let's start from the very beginning. We're going to create a function that gets the nearest nav point to an actor. And as an input, it's going to take an actor. And for an output, it's just going to send out a vector, which is going to be a valid location that is on the NavMesh. Now before we get going, I've just got the actor bounds and I'm drawing a debug box. So if we go back to the event graph and call our function and plug the actor in here, we can see the actor bounds. And the actor bounds are important in the calculation here because it helps us determine how far away from this object we need to move before we get into the NavMesh area. Now, calculating the bounds is a more advanced approach, and it's probably not necessary for all games. There's a much more basic approach we can take that's probably going to work for your game. So in the first part, I'm going to do an easy implementation that's probably going to work. It does not account for the actor bounds. And then in the second part, we're going to do the more detailed approach, which will account for the actor bounds, but it's a little bit more complicated. So you can skip to which part you want to do, the simple or the more advanced. Both of them will work. So let's get started with the simple approach first. Grab the actor, and we want to get the actor location. So the actor that we're passing in here, in this case, this is the sphere. It's the target that we're trying to move to. Now I'm creating this blueprint on my character itself. So I also need the character's location. I can do get actor location and a reference to self. And we want to determine the direction between these two. So get unit direction from the actor to the character. So all we are determining right here is the direction from this actor to the character. Now, at the moment, the transform for the sphere is in the center of it. So right now we are at the center, but pointing towards the character. Now we need to move away from the center by some distance. And that distance is a combination of the actor bounds as well as the agent radius on the recast NavMesh. On the generation section, we can see the agent radius is set to 35, and that determines how much of this white area is generated. So if I lower this to 10, it's going to shrink down. And if I go to 1, it's actually it's as small as it's going to get. But bringing it back to 35, this value right here is what is determining how much white space there is. And that's what this multiplying value is doing. If we multiply here and convert this to a float, double precision, whatever number we multiply here is going to move away from the sphere. So it needs to be at least 35, but it also needs to go further than that. Now, one thing we could do is get the capsule component and get the radius. Get capsule radius. And this will return us that 35 value. In my case, the capsule radius is set to 34, but close enough. So we could plug this in here or even multiply it by 2 so that we get the full character size, not just his radius, and then we could plug it in here. But because we know what the value is, it's 35, we could just go ahead and put 70 in right there. Now at the moment, this vector is at 0, 0, 0, even though it's pointing in the right direction. So we need to move it to the actor's location. So get the actor's location and add it to this. And I'm going to draw a debug sphere at this location just to get a visual of what we've calculated here. Okay, there is the debug sphere. And what it is it's starting from this actor and pointing towards the character, and it's moved out by 70. Now it currently isn't over the green area, and that's okay. We could either increase that value, so change it from 70 to 100, and now it has moved into the NavMesh area. But if the actor was smaller than the sphere, then a lower value would have been fine. And regardless, we don't have to be over the NavMesh here because this is the starting point for our search, and it's going to move towards the character from there. So I'm going to leave it at 70, and what we want to do with this point is project point to navigation. But I know at 70, it's not going to find navigation there. So here's how we're going to handle it. Starting from the very beginning of the function, let's go into a for loop. Now, the number of loops you want to do is up to you in your game for how far you need to search. I'm just going to do 10 loops here, so 0 to 9. And project point to navigation returns a Boolean value that will be true if it found a navigatable point. So let's do a branch here. And if it found a navigatable point, then we can just go ahead and return and pass in that projected location. But project point to navigation has a query extent, which is how far in a cube it's going to search for that navigatable point. Now on the first check, we really don't need a cube. We can just pass in 0, 0, 0, and it will check a specific point. So what I'm going to do is multiply the index by a number, and this number can vary depending on your game, but I'm just going to use 10. And I'm multiplying the index by 10, and then I'm going to plug that into the query extent. So on the first loop, it's going to be 0, and it's just going to be checking for a point. If that fails, it's going to increase to a size of 10, a 10 by 10 cube, and check that. If that fails, it'll check a 20 by 20 cube until it finally finds a navigatable point, and then it will return that location. Now this is going to stop with a cube of 90. So if you don't think that you're going to find a navigation point within 90, then you could do more loops, or you could increase this value to search a bigger area. So to help show how this search is working, I'm going to draw a debug box. The center is our location, and I'm going to split the struct pin so we can plug in an X and a Y value. Now I've made a small mistake here that we want to make the Z much bigger because the Z is up and down, and we just want to search a large area for that navigation mesh because we don't know how tall our actor is. So we could have a really tall actor. In that case, we need a large Z number here. So the X value I'm going to plug in here and there. Now for my debug box, I'm just going to do a Z of 100. And here is what we get. So the point in the middle is the first loop. That was our value of 70 away from the sphere where it started searching for a nav mesh. It didn't find one, so it increased to 10 and then 20. And it looks like it should have got one on 20, but that's just because my camera is perspective. There we go. So then when it got to 30, of course, it finally found the nav mesh. And you can see from the side here, all the tests failed until it got to 30 where it finally found the nav mesh. So it's returned us a point on the nav mesh that is essentially right on the line, which is what we want. And if I never return true, it's going to finish all 10 tests. So you can see what it looks like finishing all 10 tests. Normally it wouldn't have made it this far because it would have already found the navigation mesh and the loop would have ended. Now one thing to consider is that when it gets to the end of the loop here, unless you do more loops all the way up to 20 or increase your step size, then it's never going to find a navigation mesh beyond this. And that's where the more advanced version that looks at the actor's bounds comes in. But for now, for this application, we have something that works. And given that we can modify this value here to increase the cube size, and we can also increase the number of loops, this is probably a good enough solution that'll work for most games. So let me disconnect my debug here, and we want to return that location. Let's go back to the event graph, and once it's found that location, plug it into the AIMoveTo, hit a compile, and let's see what happens. He's gotten pretty close. Of course, I think I've got a large acceptance radius here, so if I change that to 1, okay, look at there. I guess you probably can't ask for a better result than that. He's got 1 foot in and 1 foot out. So that's the basic version. Let's move on to the more advanced. Now all actors have a bounds, which is a cube or a rectangle around it. And what we need to calculate here is a point that is actually on the bounds. So given any direction, the character could be anywhere around this actor. We want to point towards that character and then calculate a position that is on the edge of the bounds at that point. So as the character moves around in a circle, the point would move down this edge of the cube, then down this edge of the cube, this way and this way. So that's what this function is going to do. So I'm just going to use the same function that we've been working with. Later on, we're going to use this project point to navigation. But we can delete these 4 nodes here, the multiply plus, and just go ahead and get rid of those for now. And if you're just starting this tutorial for the advanced part, then go ahead and create these 3 nodes. And from this unit, we want to get a radian. So get the vector heading angle. And from here, we want to get cosine, radians, as well as sine. Now we need to get the actor bounds. So pull off an actor and get actor bounds. And split the struct pin here because we need to get the x and divide it by the cosine. And get the y and divide that by sine. From here, we want the absolute value of both of them. So I'm just going to copy and paste that. And we want to multiply both of these values by get unit direction. So bring get unit direction over here. I'm going to do a reroute node. That way I can multiply by this absolute value as well as by this one. Now I'm going to make a comment on the top one here that says this is the true value, and one down here that says this is the false value. Because I'm going to move these over into a function. But before we do that, let's make a reroute node by double clicking right here and dragging from that into vector heading angle. The reason why is because when we convert this to a function, that will leave us with the correct number of input pins if we select all of this, including that reroute node. So with all of these selected, multiply all the way up to vector heading angle and the reroute pin, I'm going to right click and collapse to a function. Now what this is doing is calculating a point that is on the actor's bounds. So I'm going to call this get point on actor bounds. And it's created an input for the direction vector as well as the actor. So let's double click on this, and with the absolute value here, we want to check if that is less than the absolute value from the bottom part. If that's true, B for branch, then we want to return, and we're going to have to specify an output for the location. This is a valid location that is on the NavMesh. We're going to return this value with true. And copy and paste so that with false, we're going to return this lower value. Okay, so we're passing in a direction and an actor. Based on that, it's determining a point that is on the edge of the bounds, and it's returning that location to us. Project point to navigation was giving me an error, so I'm just going to delete that for now. And we're not starting our loop for the search yet because we first have to determine the point where we're starting our search. So I'm going to connect the execution here. So what are we going to do with this location? The first thing, let's see where it's at. So get actor location. We're going to add this to the actor's location. And with that, let me just draw a debug sphere so we can see where we're at. The other thing I'm going to do is connect event tick to our function just for the purposes of demonstration. You wouldn't do this when you're calling AIMoveTo, of course. So here's the point that it's calculating. And if I move the character around, you can see that it's drawing that point right on the face of the bounds in whichever direction the character is. So as the character goes around, it's calculating a point that is right on the edge of the bounds, which is really useful because we need to get out of the bounds, and then we need to, from here, we're going to have to cross the white gap and get into the navigation radius. Luckily, all that's left now that we have this point is the agent radius, essentially, to cross the gap. And the good news is, because we wrote our code correctly, if the shape is not a square, so here we have a rectangle, we're still going to get the correct result. Okay, so right here we have the point that is on the edge of the bounds. So now we need to get a little further away to account for that agent radius that is defined on the recast NavMesh. So what we're going to do is get the unit direction, the direction from the actor to the character, and we're going to multiply this by, we could do any value here, 35. But what I'm going to do is get the capsule component and get the capsule radius, which I know if I click on here, it's set to 34. And I'm going to plug this into the multiplication. So I'm moving away once I've got to the edge of the bounds, and we've got to the edge of the sphere, I'm then going to move the agent radius distance away. And all we need to do here is add these two vectors together. So drag off of this plus this one. And now let's look at our debug sphere to see where we are at now. Okay, so we are 35 or 34 actually away from the bounds. So this is what we get. Now it looks like this is a pretty good starting point to start searching for the nav mesh. If I look at it directly from above, it looks like we are over the nav mesh here, so it's definitely going to find a point given the 34 radius. If he is right here at a corner, and if he's here on the side, it might not find one, but that's okay because our for loop extends the search out. So it's going to find one probably within by the second or third for loop. But this, you can see, is giving us a pretty good starting point to start searching for the nav mesh. Okay, so all we need to do now is implement the for loop, which is going from 0 to 9, so it's looping 10 times. And with our final point that we have calculated here, we're going to project point to navigation. And for the index, we're going to multiply that by 10. Again, you can increase this value to make your search expand to a bigger area. And we're going to split the struct pin on the extent, make the Z extent 1000 because we just want it to search as far up and down as possible. And then we're going to connect the value here to the X as well as to the Y. Now if it finds a navigation point, it's going to return true. In that case, we want to return the projected location, and we found our point on the navigation mesh. I'm going to bring the debug box back so that we can see how our search is working. The center is that point, and the extent we will split so we can plug in the X and the Y, and I'm going to do 100 for our debug box on the Z. And here's the result. It started the search right here with a point. It didn't find a nav mesh. Increased the search cube to 10, didn't find it. Increased to 20, and there it found the nav mesh. One thing to visualize this a little easier is to go to display on the recast NavMesh agent and do the draw offset to 1 so that it gets closer to the ground. But there's the results of our search. It took into account the actor's bounds. It then moved away the agent radius distance. And from there, it started doing the cube search looking for the nav mesh, which of course it found on that third loop. And then I'm curious if he is right on the corner, if it's going to find it on the first. Looks like it took 2 loops to find it. So that's what it looked like from the corner. The first point missed, and the second one was successful. So a couple considerations here. One, if we multiplied the capsule radius by 2, then we would be, actually we're a little bit too far at this point into the nav mesh. But if we were to put in a manual value here by converting this to a float, and currently it was set to 34 because it was getting the capsule radius from my character, but I could manually increase this to like a value of 50, and in my specific level here with a value of 50, that's probably going to find the navigation point in the first try. So you can increase this value. You don't have to use the capsule radius here. You can also increase the number of loops it's doing. If, for example, it's not finding a nav mesh, you could increase the number of loops. And you can also increase the size of the search area. So each loop, it's increasing it by 10. You could increase it by 20, and that, of course, is going to find the nav mesh a lot quicker. So I think our function is complete at this point. We'll go back to the event graph, connect AIMoveTo, and see if we can get the character to move to his location here without failing. Well, we're getting a bunch of aborteds because I still have the event tick plugged in. So we'll disconnect that and see what we get. So once again, he's got 1 foot in and 1 foot out. So that's a pretty accurate movement, pretty accurate calculation, because his center point is right in the middle. So essentially, his transform has been moved right to the edge of this navigation mesh. So that's a wrap for this one. I hope this helps get your characters moving around the nav mesh and using AIMoveTo without getting all those crazy errors from it. But at least with this method, we are determining a location that we know is always going to be on the nav mesh before we pass it to AIMoveTo. That way AIMoveTo isn't going to give us all these failures with unable to complete the pathfinding and whatnot. So if it was a helpful video, hit that like and subscribe. I appreciate your guys' support as I continue to grow towards 100,000 subscribers and get my next game released. So I'll see you guys in the next tutorial. See you soon.